Guys, I welcome you to my YouTube channel. In today's video, we are going to look at how MediaTek chipset charging IC works. And in this type of charging IC, we are having single transistor charging IC. Okay, so in most of the MediaTek phone, you will see this type of transistor charging circuit. So I'm going to walk you through step-by-step process of troubleshooting this type of charging IC. Alright, now let's dive in. This is our MediaTek charging IC, and this type of charging IC is single transistor charging IC. But we also have double transistor charging IC. In double transistor charging IC, you will get two transistors here. This transistor will be 2. Now this MOSFET will also be 2. But in this single transistor charging IC, we are having one transistor and one MOSFET. Now the meaning of this MOSFET stands for metal oxide semiconductor field effect transistor. It is also a transistor, but it is the higher form of transistor. Okay, so now this is the block diagram of this single transistor charging IC. So here we have our charging port. This is our ground, and then this is our V-bus line. You can call it V3 or you can call it V-bus. So now we have a diode here and a capacitor here. There are other models that you will meet, and then you will see more than one capacitor. So in this block diagram, I only include one capacitor. Now in other models, you might not see OVP, but you will see a coil instead of OVP, and then you will see a diode and other capacitors. So it also acts as a protective component. But in this case, we have OVP. OVP stands for over voltage protection. So this OVP helps to protect more than 5 volts from entering into this charging IC. The OVP is only programmed to take in 5 volts and send out 5 volts. So if more than 5 volts comes, like let's say 8 volts, this OVP will not allow this 8 volts to pass through to this other side, because its main work is to prevent higher voltage from passing to this side. And it is being programmed to only receive 5 volts and send out 5 volts. So if the voltage is more than 5 volts, it's not going to allow it to pass. So that's the work of OVP. And if this OVP is damaged, you can jumper it. But there's a risk there if you jumper it. If you jumper it, it means that there is no protection in this line. So if there's a voltage spark and then more than 5 volts comes to this line, OVP is not there to protect it. So it is always advisable that anytime you remove OVP IC, that you should try and replace it back. But if you don't have the donor board to take the OVP and replace it back, you can bypass it. Okay, so if this OVP is damaged, you can bypass from this capacitor to this capacitor. Now this diode is connected in forward, it's connected in reverse bias. Sorry, is reverse bias. So this diode also acts as a protective component. It protects if more than 5 volts comes in before it even gets to this OVP. This diode will channel those voltage to ground. So in a situation it passes this diode, it will not pass the OVP. So now this is our V-bus. So you also get 5 volts here. Now when it comes to this line, we have 3 lines. One line goes to VCDT, another line goes to charge LDO. Then we also have another line that enters this our transistor. This is the emitter. Emitter stands for input. It means input. Okay, now let me explain something to you here. We have a transistor here and we have a MOSFET here. The pins, we normally have 3 pins, but here we have 8. But basically it's 3 pins. So I will explain why I say it is 3 pins. So in the first pin we have here emitter. This C stands for collector, this B stands for base. Okay, so if you see this, you know that this is a transistor. But anywhere you see this other pin that are labeled S, D, G, this is a MOSFET. So this is a source. The source also acts as a meter, which is the input, and the meter is input. So this is the drain. The drain also acts as a collector, which is output. So the drain is output. So this is the base and this is the gate. They both act as a controlling pin. So this gate and this base, they controls it. So you will see this label on transistor, and you also see this label on MOSFET. I just want to explain to you so that when we get to this point and this point, you will not get yourself confused. So now, after ensuring that you see 5 volts from this pin, this capacitor, let's say, there's a line that goes out, and this is our PMU, power management unit. This is our power IC. Okay, so now this line will go to our power IC. The function of this line is that it helps to detect charging. If this line is faulty, your phone, if you connect your charger, it won't show the charging logo. So there will be no charging logo. If you don't get the charging logo, the first line to check after the OVP is this line. But if you see a charging logo and the phone is not still charging, you know that this line is okay, but you can still go on to test it. Okay, so you have 2 resistors here. One resistor is connected in series and the other resistor is also connected in parallel, which is one pin is connected to ground and the other pin is connected to the 5 volt line. So 90%, or let's say 95% of MTK chipset phone that you will have or that you will see, this resistor is R1. It carries this 330K resistor. So this other R2, which is connected to ground, will carry 39K in 95% of the MTK chipset. Okay, so this is divided circuit. But in another video, I will explain how divided circuit works. So in this video, I'm not going to explain because I don't want this video to be long. I want it to be very brief and short. So you have this voltage here. This is a divided circuit. On this side of the resistor, you will get 5 volts. But on this other side, you will get 0.5 to 0.9 volts. Because there is a divided circuit here. The work of a divided circuit, it helps to reduce voltage to the required voltage that you want. We also have a single divided circuit and we have a double divided circuit. In a single divided circuit, you will see 2 resistors. One is connected in series and the other one is connected in parallel. But in double divided circuit, you will see 3 resistors. 2 resistors are connected in series and 1 resistor is connected in ground. So in this divided circuit, we have formula for it. So in my next video, I will explain how divided circuit works. So this other side of the resistor, you will test 5 volts, you will get 5 volts here. If you don't get the 5 volts, know that it is within this line that the phone has fault. So you have to look for the open circuit, where there's an open circuit and then you jumper it. But if you get 5 volts here, then this other side you will get 0.5 or 0.6 to 0.9 voltage because there's a divided circuit here. So this line is VCDT line. This line goes into our power IC. It helps our power IC to detect that the charger has been connected. So the power IC will show the charging logo. So now let's move to the next line without wasting time. When we get to the next line, we will have another line that comes out from the same 5 volt line, from our VBus line. The same another line will comes out, and then it is called charge LDO. That is charging load dropout. It will goes to our power IC. There is a resistor connected in series in this line. Now there is 2 kinds of connections. We have series connection and parallel connection. If you don't know how series connection works or how parallel connections work, you can write on our comments that I should explain how series and parallel connection works, and I will do another video for you whereby I will explain how series connections and parallel connections work. Okay, so on the first side of the resistor, in this model we have 1.5k resistor. This K stands for thousands, so 1.5 thousand resistor. So in this side of the resistor we will have 5 volts, and on the other side you will have 2.8 volts. If you don't get 2.8 volts, you have to change this resistor. So if you have 2.8, if you don't have 2.8 volts here and then you have 5 volts here, you will test this. You have to change this resistor, but before you change it, you have to read this resistor. Turn your meter to ohms reading. Check if this resistor will have 1.5k. If it doesn't give you 1.5k, you have to change this resistor. So this resistor helps to step down this 5 volts to 2.8 volts. I'm showing you the step-by-step process of troubleshooting this type of charging IC. So now this 2.8 volts will come to our power IC. Now, still the same line, there will be a line that comes out from the charge LDO line and connect to our MOSFET. This is our MOSFET. And it will connect to our MOSFET pin that is called gate. These gates act as a base. So they control. The work of a gate pin is to control. So this is the gate, this is the pin that turns on this MOSFET. So now you get 2.8 volts here, and this is where you get it. If you don't get 2.8 volts here, you have to work on this line, especially this resistor or this V-bus line. Alright? Okay, now you get 2.8 volts here. So now let's come to this our transistor charging IC. Let me explain it to you. The emitter pin will get the 5 volts, and now there's a diode connected internally. But before I explain the functions of this diode, let me first explain why I connect these 3 pins, these 6 pins together. I told you earlier that in a transistor there is basically 3 pins: emitter, collector, and base. But in this case we have 8 pins. So why do we have 8 pins? It means that 6 pins are connected together internally. So if you use some meter to check it, you will see that these 6 pins are connected together. So now basically we have 3 pins, which is emitter, collector, and base. I hope you understand. So now the work of this transistor is that the voltage from the gate, from the emitter, the voltage from the emitter have to pass to the collector, and the line of this our collector is our VBAT. But it won't happen except this base is triggered, and before this base is triggered, it is this MOSFET that will trigger this base. So we have a diode. I just drew this diode to explain something to you. Now when that 5 volts enters this emitter pins, it's going to, this diode is connected in forward bias, so it goes to pass through this diode and comes to our base pin. And when it comes to our base pin, you will not get the 5 volts here. You have 4.79 to 4.8 volts. And if it is 4.79, it's also the same as 4.8 volts, because if you approximate it, it will give you 8 volts here. Okay, so you have 4.8 volts in this pin. So on this pin you have 4.8 volts. Why? Because before this 5 volts travels down to this pin, it will step it down, it will give you 4.8 volts. So if you don't get this 4.8 volts on this line, you have to change this transistor. The 4.8 volts is not coming from this MOSFET, rather it is coming from this transistor and from this line. I'm taking time to explain to you how this transistor works internally. That's why I draw this diode. So now after that, this base will connect to this drain pin. This is our MOSFET, and on this drain pin you will have the same voltage that you will have here, which is 4.7 to 4.8 volt. If you don't have this 4.8 volts here, all you need to do, test this pin, the base. If you have the 4.8 volts here, you have to, and you don't have it here, you will just make a jumper from here to here. I hope you understand. So now let me explain to you how this works. You have to follow this step by step. so that you'll be able to solve this charging issue. So now the gate will receive 2.8 volts and turns on this transistor. Okay, the goal of this MOSFET is to channel voltage from source to drain. Now the gate pin controls these two pins. When this gate enables, there will be a flow of current between source and drain. If this gate is not enabled, this MOSFET is not turning on. Okay, so this 2.8 will pass internally. There's a diode connected between the gate pin and the source pin, and this diode on this side of the source pin, you have 2.7 volts to 2.8 volts. Okay, so if you don't have this 2.8 volts, what you need to do is that test this gate pin if you have 2.8 volts. If you have 2.8 volts on this gate pin and you don't have 2.8 volts here, what you need to do is that you have to change this MOSFET. It's either the MOSFET or the diode inside is faulty. So if you change this MOSFET and still you don't still get this 2.8 volts, what you need to do, leave this MOSFET, take a ground readings on this pin, take a diode readings to see if this line is connected to your power IC. If there's an open circuit on this line, it means that this phone will not charge. So if you see an open circuit here, that means it's not connected to this power IC. The reason why I asked you to take out this MOSFET is that if you don't take it out and you measure it, you still have readings, but the readings might not come from this line, this power IC, because these other pins are connected to ICs, to other ICs. So those ICs might be giving you the value. So you're thinking that it is this power IC, this line, that is giving you the value. So that's the reason I asked you to take out this MOSFET, and then you read it. When you test it and you get your voltage, it should be between the range of 280 millivolts, let's say 250 millivolts to 800 millivolts. So if you take that reading and you see the voltage, then know that this line is connected. It doesn't have open circuit. You put it back and you change this transistor, it should work. Now let me tell you how this transistor activates this. Let me tell you how this MOSFET is also a transistor, but it's the higher form of transistor called MOSFET. Let me tell you how this MOSFET activates this transistor to start charging your battery. Now, when this 2.8 volts pass from the gate to drain source, there is another MOSFET here inside the power IC. The power IC is made up of different transistors, a lot of transistors, MOSFETs, you can say resistors, capacitors, all of them are being merged together to form a power IC. So there's how it works. So there's an internally fixed MOSFET here inside the power IC. So now the MOSFET, the power IC will be working with this line. So there is a logic on how this power IC works with this line. So when this line gets 2.8 volts, the power IC will drive this line. Then it will then drive it, and then before I explain how this line works, this is how this MOSFET is internally. This is our gate, this is our source, this is our drain. So now this voltage will pass from here to here, this side, and then the power IC will drive this voltage, and then it will allow it to pass from this side. It will enter the drain side. They are all connected together. It will enter the drain side. Now this drain already have 4.8 volts. Okay, so this 2.8 volt will pass to this other side, and then they will become one internally. I'm explaining it to you internally how it works. So when it comes to this, there will be a higher voltage. Now this base will be triggered. This transistor will be triggered through this base pin. There's a certain threshold of voltage that is required to turn on this transistor. So if you only have 4.8 volts here and this source pin does not work, your voltage, this transistor will not turn on. So the power IC will drive this source and then it would, then this drain, there will be a flow of voltage from source to drain also. So this drain will meet with this voltage, and then this base will activate this transistor. It will turn on this transistor. So now the current will flow from this side to this collector. Okay, when it turns on, the current will flow, and then you will get your 3.7 to 4.2. That's why I put this diode on reverse bias. It will pass from this side. It will pass. I put another diode here because from this emitter side, it will pass. When this base is activated, it will pass to this side of the collector, and then you will get your voltage here. So most time, if you reach your VBAT, your voltage will be fluctuating. You have to work on this pin. Just follow the step-by-step process, because if you go to YouTube, you will see a quick fix solution. They will just say change this, do this, change this resistor, take out this, change this, but they won't tell you why you are changing it. Okay, and your phone might not have the same issue with their phone. Maybe it is one component, maybe it is this transistor, it is this MOSFET that is faulty in their own phone, and they remove it and replace it. Now on your own phone, there is an open circuit here between the source and the power IC. So now they ask you to take out this MOSFET and you replace it, but still your phone is not charging. So that's why I take my time to explain step-by-step process, so that you will understand. You will not need to go to YouTube and check quick fix solution. You will have to troubleshoot it on yourself and understand it. There is a lot more to this, but the knowledge I'm giving you is okay for you to troubleshoot any charging IC, any related charging IC that carries this single transistor. So on this side, you will get your VBAT voltage 3.7 volts to 4.2 volts. Okay, so this will charge your battery. And on my next video, this is a sensing resistor. This is a sensing resistor. Okay, so now there are two lines before and after this sense resistor, and this two line goes to power IC. On my next video, I will explain the functions of this line and the faults that your phone will have if this line is broken or if this line is faulty. And on MediaTek chipset, if this line does not work the same way it works on Qualcomm, even SPD. So on my next video, I will explain it to you. And I put a nose cut point here. I will also explain in another video how to count IC, so you know how to count your IC. So we count this IC anti-clockwise, not like this, but like this, anti-clockwise. So this is 1, 2, 3, 4. 4 is our base, then 5 is our voltage. The reason is that there are some model that you won't see the schematic diagram, so that you will know which pin is the fibers and which pin is the base. Okay, so now when you just count it, you know that the fourth pin here is your base, and your fifth pin, which is your number 5, is your emitter. So this is how this charging circuit works. On my next video, I will explain how double transistor works. On that one, we have 2 transistors and 2 MOSFET. Okay, please remember to subscribe to our channel, like our video, comment, and also share these videos to your friends and people that need this video, because there are a lot of people that are still limited. They don't know how this circuit works. So share these videos to them. Okay, thank you, and see you again on my next video.